This lesson shows how to graph linear equations from slope-intercept form. Graphing lines or linear equations from slope-intercept form is effective because in slope-intercept form, the equation contains the y-intercept and the slope of the line. You can graph the line by starting at the y-intercept and using slope to find other points on the line. Then draw a line through the points and you have a graph. If you begin with an equation in standard form, you need to convert the equation to slope-intercept form. In this example, subtract 2 from both sides of the equation. Then, divide both sides by -3. Be careful on the right when you divide by -3. -2 divided by -3 gives positive 2 over 3x. And 6 divided by -3 gives -2. So this linear equation has a slope equal to 2 over 3 and a y-intercept at -2. Start the graph by drawing a point at -2 on the y-axis. Remember, slope is rise over run, so from the y-intercept, go up 2, rise, and over 3, run to the next point. Then draw a line through the points, and you have a graph. Here is a more complete graph of the equation. Starting from the y-intercept, graph at least one point to the left and one to the right. Also, extend the graph at least one point beyond the x-intercept. Finally, check your graph. Select an integer point on the graph, like 6, 2. If your graph is correct, the coordinates of the point should be a solution to the equation. Substitute x equals 6 and y equals 2 into the equation. 2/3 times 6 is 12 over 3. Then 12 over 3 is 4. And finally, 4 minus 2 is 2. And the graph checks. For equations with positive slope, the graphs go uphill to the right. For this example, the slope is positive 1 over 2, and the y-intercept is -3. The line begins at -3 on the y-axis and goes up 1 and over 2 to the next point. For equations with negative slope, the graphs go downhill to the right. For this example, the slope is -2 and the y-intercept is 3. The line begins at 3 on the y-axis and goes down 2 and over 1 to the next point. When you graph this line up 1 and over 2 to the right, you also have to graph the line down 1 and back 2 to the left. You have to graph the line in both directions from the y-intercept. In a similar way, when you graph this line down 2 and over 1 to the right, you also have to graph the line up 2 and back 1 to the left. You have to graph the line in both directions from the y-intercept. Here are some potential mistakes to watch for. When the slope is not a fraction, it is sometimes hard to decide what is rise over run. If the slope is equal to 2, it is really equal to 2 over 1. So for this example, the line starts at -1 and goes up 2 and over 1. For the equation y equals x plus 3, there does not seem to be a slope. You have to read this as y equals 1x plus 3. The slope is 1 over 1. So the line starts at 3 and goes up 1 and over 1. For the equation y equals -x plus 2, there also does not seem to be a slope. You have to read this as y equals -1x plus 2. The slope is -1 over 1. So the line starts at 2 and goes down 1 and over 1. For the equation y equals 1/2 x, there does not seem to be a y-intercept. You have to read this as y equals 1/2 x plus 0. The y-intercept is 0, the origin. So the line starts at the origin and goes up 1 and over 2. The lines y equals x and y equals -x are so simple to graph, they're hard. You have to read y equals x as y equals 1x plus 0. The line goes through the origin, uphill to the right, with a slope of 1. For the line y equals -x, you have to read it as y equals -1x plus 0. The line goes through the origin, downhill to the right, with a slope of -1. Remember to start your graph on the y-axis, not the x-axis. It's called the y-intercept because it's on the y-axis. And finally, sometimes it's hard to remember, is slope rise over run or run over rise? Remember that rise is in the numerator, the value that's up above, like the rising sun.